We're looking at solving quadratic equations using another method apart from factorization. This one involves what's called the quadratic formula, and we've got here a quadratic, it's a monic, and we've got a equal to 1, hence the name monic. Let's see if we can factorize this one and solve it like we saw it previously. So from a previous work, we need to decompose the middle term, and we've got x squared decomposed middle term minus 1 equals 0. And let's look at, okay, we need to find two numbers that multiply together to be -1, and the same two numbers add together to be -1. Okay, so two numbers that add together to be negative and multiplied. Well, there's not many ways we can get -1 when we times things. It's 1 times -1 and -1 times 1. No other way of getting any integer values to work that way. And there's certainly not going to be a difference of 1. 1 and -1 are a difference of 2. They're not going to be, when we add them together, they're going to be 0. They're not going to be -1. So we can't use that to decompose the middle term and get some integer coefficients. So it would be pretty nasty to try and find maybe some decimal or fractional values. So there's hopefully another way, and the other way is called the quadratic formula. And the quadratic formula is written as such, and x means the solutions. Now with a quadratic equation, it's important to note that we could get, this is very important for this video and the previous one, and just to emphasize that, I'm going to create a nice little border there, and we could get two solutions, so two answers when we solve it. Other words for solutions are roots, zeros, x-intercepts. Those four words essentially refer to the same thing in different contexts. Intercepts. Okay, so root, zeros, x-intercepts, we can get two solutions, 1 or 0. Okay, so it depends on it. It could be 2, 1 or 0, and we're going to look in a later video graphically why that is, as well as algebraically. But at the moment you need to know this, for any quadratic equation there could be two solutions, 1 or 0, and we're only talking about it with real numbers, because if you do a specialist maths, we know that sometimes things can have complex roots, but that won't be covered in this subject. We're only looking at real numbers. So when we say there are no roots, there are no roots in the real number system, and that's the only system we have to worry about in the subject we're doing now. So getting back to this quadratic formula, it's complex, but it's something you need to know. So here we go. We've got x equals, x means the roots. Some people even put 1, 2 there, meaning there could be 2. But x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Recall that we're talking about a x squared plus bx plus c equals 0. And it's no accident that these a, b's and c's are the same as these ones here. So that's not a coincidence. That's fact, because we can look at a derivation of this and see that these are the same coefficients A, B and C. And if you're, before we go ahead and you're thinking, why won't he do this question? He will, but there is a derivation, and if you want to put the video in pause mode to look at where it comes from, there's a bit of a derivation of the formula there, starting, as you can see, at our quadratic and continues on with the final statement there that the axis of symmetry, that the graph of this function, because the graphs of quadratics are parabolas or variations on that, they have axis of symmetry, and the axis of symmetry we'll learn later on is negative b over 2a, and we're going to apply that later on. So the axis of symmetry can be derived from this general formula. The axis of symmetry is the line of equation negative b over 2a, and that will give you some sort of axis of symmetry. It'll be a vertical line in a lot of cases. However, we're getting ahead of ourselves. That negative b over 2a will be explained in a later video, and it's not essential that you know the derivation that you can see down the side there, but some people are interested in where things come from. So getting back to the equation here, as you can see, we got nowhere factorizing it. What about if we try and use a quadratic formula to solve that? So we need to identify A. So A equals 1 in this case, B equals negative 1 because that's plus negative 1, and C equals negative 1 as well. Now the good thing about this too is that if you have non-integer values for A, B and C, this will still work, whereas factorization gets very dicey if we want to consider non-integer values for A, B and C. So this will still work when A, B and C are not integers. So we're looking at a pretty simple one here. Let's have a look at when we sub everything in. Okay, so here we go. We've got normally I would write the formula down here, but we can still see it further up there, so I'll leave that there. Write your formula down, and then we go negative of whatever b is. Now b is already negative 1, so it's the negative of negative 1, or negative 1 times negative 1, which is positive 1, plus or minus, because there could be two solutions, square root of b squared. So if in doubt, put it in brackets, minus 4 times a, which is 1, times c, which is negative 1. All of it is divided by 2a, which is 2 times 1, which is 2. And be careful of doing things in the correct order. So negative 1 squared is 1, 4 times 1 is 4, times negative 1 is negative 4, so 1 minus negative 4, all over 2a. So I'm doing things gradually and in the correct order of operations. Now in here, inside here, which is called b squared minus 4ac, the name of that is called something special. It's called the discriminant. Discriminant is the b squared minus 4ac, which sits under the radical or the square root sign. It has a symbol, a little triangle there, delta. That's a little triangle, and you see delta has characteristics. It called the discriminant. It's a bit of a telltale. It will tell you if the value of what's under the square root sign is 0, not that it is there, there'll only be one solution. So that's this case here. If it is bigger than 0, positive value, there'll be two solutions. So the plus or minus will then kick in. If it's less than 0, negative, there'll be no solutions, because what's going to happen then is you're going to be trying to take the square root of a negative number, and in the real number system, that's a no-go zone. It's not going to happen. So that makes sense why that works. So that's called the discriminant. So let's get back to the question here. We've got working out what the discriminant is. We've got 1 minus negative 4, which is 1 plus 4, which is 5, square root of 5, and that's over 2a, which is 2 by 1, which is 2. And I've just noticed I probably shouldn't have an a there by that stage. I've already substituted in. So we've got an answer. We've got a solution. It's 1 plus or minus root 5 on 2. Now, you might not be satisfied that it's an answer, but that is a number. That's the exact value. So that's two numbers, because have a look, you've got a plus or minus, so you could extrapolate that if you want to. You don't have to do this. So that means x equals 1 plus square root of 5 over 2, or x equals 1 minus root 5 over 2, and that's the exact answer. It's only if you have practical problems where you need a numerical answer that you would enter these two solutions into your graphics calculator and get an approximate decimal answer. So there are your two solutions. In the near future, we'll see how this links to the x-intercepts. Now, you might have noticed before that one of the other words we can use for solutions is x-intercepts, and this particular quadratic here creates this parabola, and more about that in the future. But we can see that if you were to go ahead, and I challenge you to do this now, use a quadratic formula to get those two values that you see there on the diagram. The two values are written there. So it's negative 2 minus square root of 15 on 3, or negative 2 plus the square root of 15 over 3. See if you can do that as an extra challenge, and more about that later on.